Following on from the previous video, we used the integration by parts formula here in order to integrate this. So we found that whenever you have a high power here, it becomes very tedious because whenever you apply this integration by parts formula, if you have a high power here, you will need to repeat this process again and again and again, and it becomes very tedious. Well, in the previous video, we got to this stage here. If you integrate this, it would take you to this. Tidy up, it would take you to here, and then repeat the process again, and it will then take you to here. So we are at this stage here where if you integrate this, it will give you this thing here. Okay, and by the way, you still need to integrate this. So we know the answer. So when you integrate this, it will give you this. Okay, we know the answer, but it's very tedious. So now we're going to develop a neater, cleaner way of doing it. So let's say we're trying to integrate the same thing, which is this thing here times this thing here. So you are trying to integrate this. So that's this bit here, and then sine of x is this bit here. If you look at the integration by parts formula here, if you look at this here, this is our u here. So that's our u here. So each time, so you start with your u. By the time you get to here, you get your u prime. So each time you repeat the process, you differentiate the u part, and then when you repeat the process again, this thing here will then, well, you would need to differentiate it again because you're repeating this same process. And then if you look at your v, this is your, you start out with this being your v prime. So you start out with this being your v prime. By the time you get to here, it's the normal v. So it's really you integrating. So you start with your sine of x here. You start with your sine of x here. Each time you need to integrate it. So each time you need to integrate it. So every time you repeat this process here, you would need to integrate this each time. You would need to integrate this. Every time you repeat this process here, for this one here, you would need to differentiate each time. So build yourself a table like this. Oops, hang on. So build yourself a table like this, and then from here, if you look at this here, the first step would be uv. So the first step would be u getting u times v, because remember this here is v prime. Okay, this is v prime, and then here it will be your v. But if you look at the formula here, if you let this to be your u, you let this to be your v prime. So don't forget, this u here is this u here, and then v prime, this is v prime. But if you follow the formula up here, if you follow the formula, it's saying that if you want to integrate this, then just get u times v. So get u times v. Remember, this is v prime. This here is v. Okay, so if you want to integrate this, get u times v. So get u times v. So that would be x to the power 3 times minus cos of x, and then you would need to repeat. Well, if you repeat this process here, the next one, which is this bit here, don't forget, the next one would be this times this, because if you repeat the process, it will give you that. And by the way, when we were repeating this process here, the sign changes. So when we were here, this times this here would be negative, and then this times this here would be a positive. And then if you repeat the process, the signs would change. It would be negative. The first block would be positive, the next one would be negative, and then the next one would be a positive, and so on. So just notice that the signs alternate. So hang on, let's start again. So we're trying to integrate this. So this is our u, and this is our v prime. If you follow the formula, it's saying get u times v. So get u times this thing here. Okay, so that would be x to the power 3 times, so that would be x to the power 3 times minus cos of x. And then the next one, this whole block here is a positive. The next one will be a negative, and then it will be this times this. So that would be 3x to this, okay, and then times that, which is minus sine of x. And then the next one would be this times this. So that would be, so this is positive, negative, and then the next one would be a positive. So positive this times this. So that would be 6x times cos of x here. And then so if you look at this here, this don't forget we were trying to integrate this, and the overall answer was this. So now we're comparing our new method here to our older method here. So hang on. So if you look at this here, this block here is this, and then you've got your minus, and then this thing here is this, and then this thing here is this. So when you look at your table, you still need to integrate the last part. The last part being this, you still need to integrate this. Okay. So yeah, you just remember that. So if you're trying to integrate this, it would be this. The first one would be this times this. So this here would be a positive. Okay. And then so that would then give you x to the power 3. Hang on, let me start again. Sorry. The first part would be x to the power 3 times x to the power 3 times minus cos of x, and then the next one will be this times this, but it would be a negative. Okay, so that would be a negative 3x squared times this thing here, which is minus sine of x, and so this is positive, this is negative. The next one would be this times this, and it will be a positive. So positive, negative, positive. Okay, so the next term will be a positive this times this. So that would be 6x and then times cos of x, and then the last one you need to integrate this. Okay, you need to integrate this. So you can do this in your mind, and don't forget positive, negative, positive. This one here will be a negative. Okay, so then you would need to integrate this. Okay, so that would be whatever. Okay.